Welcome back. This is the second lesson recording for IM2, September 5th, 2020. So where we left off, we've done one dilation with a scale factor of 3. Now we're going to do a scale factor of 2 from this original image or pre-image with the center of dilation point P. Okay, so now to figure out the points, each of the vertices, corresponding vertices of the image after it's been dilated for 0.5, that means it's been shrunk by half, right? Or it's dilated by half, or it is going to be half the size. So we need to figure out how far this point is from the original center of dilation. That means 1, 2, 3, 4, 5, 6, 7, 8. I count 8 to the right. So that's 8 units to the right and 2 units up. Okay, so that means the image is going to be half the distance of however many units to the right. So instead of 8 divided by 4 is 8 divided by 2 is 4, so it's going to be 4, 1, 2, 3, 4 up from the dilation point, and instead of 2 divided by 2 is 1, so this is going to be the corresponding point to this. Let's do the same with another point. Let's try this point. Okay, this point is how many units? This was 8, 9, 10, 11, 12. So that was 12 units to the right, and 1, 2, 3, 4 units up. Okay, so that means the new image is going to be not 12 units from the point of dilation, but half of 12, which is 6, which is here. This is 6. And then instead of 4, it will be up by 2. Because 4 divided by 2 is 2. Okay, so this is let's label this as A, B, C, C prime. And then this will be my A, B. So this will be my B prime. Okay, and then let's call this D. My D point is again 12 to the right, but 2 down. So instead of 12 to the right, it will be 6 to the right. And instead of 2 down, instead of 2 down, it's going to be 1 down. So this is going to be my D prime here. And then finally my my A prime. This is 8 units to the right, 2 down, so it's going to be 4 to the right and 1 down. That's going to be my A prime. And if I was to connect all the vertices, this will be my dilated image. Okay, all right, so now I want you to have a quick observation right now on comparing the pre-image or the pre-image to image. Okay, pre-image to image. What do you notice about corresponding angle measures? So what do you notice about, say, this angle, oops, this angle and this angle? They look the same, don't they? Okay, what about this angle and this angle? Those two angles are corresponding. Angle C looks same, and we know for sure this angle and this angle are the same. Why? Because they're on the grid line. That means they're perpendicular, and this is also perpendicular. I should write perpendicular symbol. Okay, so what do you know about corresponding angles? They're congruent. Okay, now what do you notice about side length relationship? So if I was to compare, let's compare this side. Oops, this is the side and this side. Okay, what do you think the orientation? Okay, do you think if these two lines extended forever, do you think they would ever meet? Well, no, we know for sure because it is along the vertical grid. So the vertical grid will never meet. So these two lines seems to be parallel. What about this line and this line? They for sure look parallel because it's on the horizontal line, and this line and this line look parallel for sure. What about the final line? Okay, that's the little bit more tricky one. Okay, but it is going 2 down and 4 up. So if I was to transfer this to here, it will look like this point here, and 2 down and 4 to the left. So it will look like this. And again, this line and this line. Oops, I think I made a mistake. No, I didn't. Okay, this line and this line, they too are parallel. So what do we notice about the sides? They are all parallel to each other. Okay, close. All right, so let's do the very last one. Okay, now this time, point of dilation. Point of dilation is inside. Okay, the scale factor is 2. How do I go about finding the vertices? You just do the same thing. You find how far the vertices are from the center of dilation and multiply that by scale factor. So if I was to look at this point, let's name this. Okay, let's name this as A, B, C, D. Okay, then if I was to look at A prime, okay, so that means I know that it is 1 unit down and 2 to the left. So 1 down, 2 to the left. So the new the A prime is going to be, instead of 1 down, it's going to be 2 down. And instead of 2 to the left, it's going to be 4 to the left. So this is going to be my A prime here. Okay, now let's do the same thing with B. This is B. B is just 2 to the left. That's easy. So instead of just going 2 to the left, I am going to go 2 times 2 is 4 to the left. So it's going to be my B prime here. Oops. So I made a mistake here, didn't I? Okay, so B prime is right here. Okay, what about C prime? Let's do the same thing with C prime. And C is 1 unit to the right and 3 units up. So instead of going 1 to the right, I am going to go 2 to the right. Instead of going 3 up, I am going to go 3 times 2 is 6. 3, 4, 5, 6. So this is going to be my C prime. And then let's do finally D is 1, 2, 3, 1, 2 to the right and 1 down. So instead of going 2 to the right, I am going to go 4 to the right. And then instead of going 1 down, I am going to go 2 down. So this is going to be my D prime. Okay, so let's connect the dots. And let me use a white yellow line. Okay, so then it will look like this. Oh, I made a mistake. Okay, great. So this is, let me redraw the original so that you can see clearly. This is the original. This is the pre-image, and this is my image. Okay, and you can tell from here that again the angles are preserved, because we know that this is 90 degrees, this is 90 degrees, and this is 90 degrees, and this is 90 degrees, because they're on the exactly on the grid. Okay, and indeed this angle and this angle is the same, and this angle and this angle measure is indeed congruent. Okay, and likewise the lines are again parallel. These two lines are parallel to each other, and we know that these two lines are parallel to this line, and indeed this line and this line is parallel, and this line and this line, these two are parallel. So the corresponding side length are parallel to each other, and the angles are preserved. And that's what I do want you to notice when you do your dilations. Okay, so we've talked about that. All right, so I want you to take notes. Okay, what is a formal definition of dilation? A transformation that produces a figure similar to the original by proportionally shrinking, that's a reduction, or stretching or enlargement of the figure from the point called point of dilation. And in math, similar polygons look alike, but they may be different sizes. More specifically, similar polygons can be mapped onto each other with a sequence of rigid transformation and dilation. So please pause the video and copy this down. And then finally, based on all the dilation exercise we did today, what conjectures can you make about the dilating any polygon? And just a quick summary of what we discovered. The corresponding side length are multiplied by the same factor. Okay, so when you think about the side length of the dilated figure, they are proportional. Okay, they're proportional, and proportional by the factor of the scale factor. And then corresponding angle measures are preserved. That means the angle measures are congruent. And then finally, the corresponding sides are parallel. Okay, so the last part was to watch the video. I am going to put this link in the lesson resources, so please watch this video. And I don't think we got to this, but we will see. Okay, finally the homework. Okay, the homework was to watch the Edpuzzle video. Depends on whether we got through this in class or not. And then second part is for you to do CPM ebook and problems. The codes are on the homepage of the Canvas, and these are the problems, and you have to write down the table of content, dilation on coordinate plane. And that's it for today. Thank you.